So this is the circuit construction kit. You can use this for the entire unit to check your answers. You can build, we're going to be solving circuits if you haven't figured that out by now. You can actually build the circuits on this construction kit and then use the voltmeter and the ammeter to check your answers. And so I'll show you how to do that another time. But for now, I said that you had to make a circuit using a battery, 2 light bulbs. Did I say to include a switch? I can't even remember now. I think I said to include a switch. 1 switch. There you go. So let's pull out a switch, an on-off switch. Now, this is what's called the virtual mode. These are what these actually look like. Drawing these pictures is irritating, and so on the right here, this is the schematic mode in a circuit diagram, and we're going to more and more be switching to the schematic mode. So we'll be using the symbols for a light bulb or a resistor or a switch or a battery. But for now, I'll keep it like this. I'll connect this with a wire. There's our switch. I'll send a wire to here, and we'll connect the light bulb there. Connect that end of the light bulb to this end of the light bulb. And we'll put one more wire in, although I could have gone straight to the battery. And then if I close the switch, woohoo! Now, the copper top of the battery is the positive end. The black part of the battery is the negative end. Electrons flow from negative to positive, but we find that so frustrating. You're going to learn later on, current is defined as going from positive to negative, because that just makes the math much nicer. Current is which way the positives would want to go if they could. I also said to toggle on values. This is a 9-volt battery, but we can actually, I think if I click on it, I can change the values of this, and you can play with that later on, but these are the default values. Our wires have 0 ohms of resistance, as does our switch. In real life, that doesn't happen. In real life, you always lose a tiny bit of energy to wires, but we're going to ignore that. Then I said to pull out the voltmeter. Now, for a voltmeter, the black end should go on the negative side. Let's say right there. The red end should go on the positive side. And for a voltmeter, you have to measure the drop between 2 locations. If I just go right there, I get 0 volts because there's no voltage drop right there. Generally, you have a voltage drop when you're going through a resistor, like a light bulb, you lose voltage. And when you're going through a battery, you gain voltage. So 4.5 volts in this 10 ohm light bulb. 4.5 volts here. You might even notice, oh, in grand total, I gain 9 volts from the battery. I lose a total of 9 volts going through the circuit. That's a good circuit. What we're really saying is, remember, since voltage is energy per coulomb, we're saying all of the charges gained some energy while going through this battery, and they lost all their energy in the form of light and heat going through those light bulbs. Then when they get to here, they gain voltage. They're given energy per coulomb. It's again sort of like lifting stuff off of the ground, giving it more height. They lose their height going through those light bulbs. And an ammeter, this is a non-contact ammeter. They're expensive in real life. Normally, to measure the current, you actually have to break the wire somewhere, and you actually have to wire the ammeter in series. Have I got an ammeter down here? Let me see. No, I don't. So normally you have to wire an ammeter in series. This is a nice ammeter because it doesn't need to be wired in. It's a contactless ammeter, and it's measuring 0.45 amps. Okay. You can have a bit of fun with this if you want, by the way. You can increase the voltage. You can add stuff. Now, I did say there was a second way to have built this. So the second way would have been to have built this in parallel. What does parallel mean? So you have a battery. You have a wire going here. You have another wire going here. And these two light bulbs are wired in parallel. And then we'll have the wires rejoin. And now we'll work our way back to the battery. How about we put a switch right here? So this will also work. Again, I want conventional current, not electron flow. I'll turn the values on. You may notice this time, if you wired it this way, you would get different answers. Here, if I measure the voltage drop in between each battery, each light bulb, I lose 9 volts, and I lose 9 volts. So this is a way to send more voltage to each of these batteries, each of these light bulbs. I keep saying batteries, but this would drain the battery away faster. And you can tell that if you look at the current that's leaving the battery, which is also the same as the current flowing into the battery. Now I'm using 1.8 amps. I'm sending 0.9 amps that way through that part of the circuit, 0.9 amps that way through that part of the circuit, and then they recombine to give me 1.8 amps. So this is the series one, and this is the parallel version, and the other one was the series version. Hope that helps. So yeah, email me your solutions and try and get them into me by this week. Again, if you're working triple shifts or something, let me know and we'll figure out something that you can do. Thanks.